given that A is a semigroup. Semigroup means that A follows two property. First is associative and second is closure. Associative means A star B star C is equal to A star B star C. Way of parenthesis is changed. Closure means for any two elements A comma B belonging to set A star B also belongs to set A. This is closure and this is associative. Now it is also given that for every two element A comma B belonging to set A, if A is not equal to B, then A star B is also not equal to B star A. In other words, if A is equal to B, then A star B is equal to B star A. It means, now if we see carefully what we do, since A belongs to A, we have to prove A star is equal to A star A is equal to A. Since A belongs to capital A, we know that A star A also belongs to capital A due to closure property. This will hold. Now let A star, this term A star A is equal to A star A star A. How we can write this? Due to associative property. Parenthesis from here to here can be changed from this place. Here I have changed parenthesis from here to between first and second term. If we consider this as first term and this as second term, now this will become second term and this as first term. See, first term into second term is equal to second into first, imply A is equal to B. In the same way, first into second is equal to second into first, means A is equal to A star A. First result have been proved. Now when we move towards second result, second we have to prove that A star B star A is equal to A. Let A star B star A is equal to C. We have supposed. Now A star B star A star A is equal to C star A, multiplying A on RHS of both these sides. Using associativity, I will change the manner of bracket. I will change A star B star A star A is equal to C star A. Now this A star A will be equal to A according to using one. This A star A will be converted to A star B star A is equal to C star A, and we have supposed that A star B star A is equal to C. So C is equal to C star A. We have supposed it. Now again taken A star B star A is equal to C. Now we will multiply A on the LHS. On the LHS, A star B star A. Now using the property of associativity, this A star will be multiplied together, and this B and this A. Now A star C. Now A star again equal to A is equal to A star C. Now we have supposed that A star B star A is equal to C. Therefore, we will write it C is equal to A star C. This is our second result and this is our third result. If you see 2 plus 3 will give you C star A is equal to C and A star C is equal to C. So C star A is equal to A star C. Now whatever it is given in question that if B star A is equal to A star B, then A is equal to B. Therefore it implies that C is equal to A. C is equal to A means C is equal to A star B star is equal to A star. A star B star A star is equal to A. Now third equation is A star B star A is equal to A star C. We have to prove this. The approach we will use here is that see x star y, we will prove x star y is equal to x and y star x is equal to x. Now since x star y is equal to y star x, it implies that x is equal to y. The same approach I will also use in third question. How? See, I have supposed this as x and suppose this as y. A star B star A multiplied by A star C. Now using associative property, A star, this is C, B star C star A star C. See, A star B star A is equal to A, therefore C star A star C is equal to will be converted to C. Using this theorem, we have used this proof to solve this proof. A star B star C. This is our fourth result. Now A star C, we have written y before, then x. A star B star C. See, we will use associative from here to here. Using associativity, A star C star A multiplied by B star C. Now again A star B star A is equal to A, therefore A star C star A is equal to A. In place of this I will write as it is star B star C. This is our fifth result. Using fourth and fifth give rise to A star B star C star A star C is equal to A multiplied by C multiplied by A star B star C. As it is considered it as x, this y, again this y, this x, according to the condition given in question, x should be equal to y. So A star B star C is equal to A star C, hence proved.